Hi guys, welcome back to Vex today. Today I'm going to explain PID Control and why you should use it. What PID is it turns your sensor feedback into precise motion for your autonomous path planning. And so how it works is that you have three variables, P, I, and D, which is why we call it PID. And this lets you be more accurate and precise. So then that way, when you do your autonomous path multiple times, it's correct. So what P does is it reacts to your error size. What that means is how high your error is. You want your error to be 0, and that's what P is gonna do. The next thing is I. I is gonna accumulate past error. So basically what that means is if your robot is swinging a little, I is gonna make sure it's not swinging at all, side to side. D reacts to the error change rate. What that means is how high your error is changing. So let's say your robot accidentally swerved a lot, the D would make sure it stayed on the path. So let's go in depth to what P is. P is proportional alone is fast but overshoots. So basically what this means is for P, you're gonna have a motor command block, and big error means a big push. But if you're near the target, you want to have a gentle push. So what this means is basically you have a number on your P when you're going to start doing this. It's going to be 0. And if you have a big error, that means you have to put a big push on your P. That could be like upping your P by 30 or by 35. But let's say your error is small. That means you have to take it down a little. So a gentle push. So what I mean by that is let's say at 35 your robot is only oscillating a little. You're gonna have to put that to 37 or like 36 or even by 0.3. Like it takes a long time to get these things correct. So after your P, you're gonna go to D. So what D stands for is derivative. So what that means is it resists rapid change, overshoot, and it smooths approach to set point. So basically, how fast your robot's going, it makes sure that no oscillations happen. And it's the exact same process as you did for your P. If it's oscillating a lot or it's not really reaching the set point, you want to give it a big push. But if it's almost reaching the set point, then you want to give it a small push. Now the last thing you want to do, if you even need it, is your I, which is your integral. This removes persistent bias. So what this means is it accumulates your past error, it overcomes friction and gravity, and it eliminates steady state offset. This is a lot of stuff. But what it really means is it just lowers everything. It makes sure everything's perfect. This is the very last step. You want to refine your P and D before you move on to the I. So as you can see in the steps, this is how you would do it. You start with P until mild oscillation. So you want oscillation to a very minimum. Then you want to do your D to damp overshoot. What that means is it's okay if it like overshoots by like a centimeter or a little less. And now the last thing you want to do is you want to add small I to remove windup. Now, to test this, you want to move some distance and you want to turn some angle. So what that means is you want to move forward for your P and you want to turn a certain angle for your D. And that's how you're gonna basically measure that. So this is where PID would help in your code. You can drive straight with encoders plus gyro perfectly. You can turn to a precise angle. It also helps hold arm position against gravity, and it stop linear slide at preset. I mean, usually in Vex V5, what you'll usually use PID for is just to drive straight and turn. but I added these two in just to show what else you could use it for. Well, to recap, what's going to happen is you want to attach your sensors, then you want to do PID for precise control. So the process is P, then D, then you want to finish with small I. You want to use PID for drive, turns, arms, and slide. And now in my next video, I'm going to show you how to implement this in C++ and how my robot actually acts on it. Last thing I want to say, sorry I couldn't upload yesterday. It was New Year's and I wanted to celebrate with my family. Anyways, Happy New Year, and I hope we all have a nice start to 2026.